Hello, this is Science for Cycle 3, Week 16, and today we're going to be talking about chemical reactions. So as usual, you can read your class the Bible verse at the top of your page, which is from Colossians 1:16, and you can just stress the part of this verse that talks about God creating things that are both visible and invisible. And you can even review some of our recent science sentences about atoms, parts of an atom's atomic number, and elements, and just review that we can't see any of these things, even with our most powerful microscopes. But we know that God created these things that are invisible to our eyes because we can see how they react and how they behave in our world. And that's what we're going to discuss more and learn more about today. So our question is, how do different elements react when they are put together? And this is going to be a really fun one. I think your classes will really enjoy it. So you can review a little bit that we've been talking about elements and molecules and states of matter over the past few weeks. You can review solid, liquid, and gases that we've talked about and how molecules behave in those different states. But then we're going to kind of change a little bit today in that we won't be talking about physical changes in states of matter, but we'll actually be talking about chemical changes where a molecule is going to break its bonds and form new bonds to become different molecules. And that's what's happening when we do chemical reactions. The big difference here is that a physical change in a molecule can be reversed easily, right? If we melt ice to become water, we can easily reverse that and freeze the water again to become ice. A chemical reaction, a chemical change where new molecules are created, often takes a lot more effort to undo or sometimes can't even be undone. So that's the big difference between a physical and chemical change in chemistry. And then you can explain that chemical reactions are happening everywhere in our world. We rely on them for a lot of things that we do. There's a couple listed there, and for younger classes you can obviously just kind of discuss them. For older classes, if you even want to show them, this is what a chemical reaction would look like if you wrote it down, if you were an organic chemist. And these are in your lesson plans as well. So you can just show them this and see if they recognize any bits of it. If they've been looking at the periodic table again, they might recognize that we've got water over here, we've got iron here, and you can explain that this big intimidating equation shows us the chemical reaction that happens when rust is formed. So when our iron interacts with oxygen and water, it eventually over time creates rust. And that's why we see rust forming on maybe a trash can lid or on an old car or something like that. It's actually a chemical reaction where molecules are being changed through this process into rust. Then the other one you can show them, again, see if they recognize any of their elements. This one, so again, big intimidating looking chemical reaction. You can see if they recognize we've got carbon dioxide here, we've got water over here, obviously they can see light. And then when those things react together, we've got this big molecule and this other molecule here that's oxygen. So what's happening here is that it is photosynthesis. So our plants are actually converting carbon dioxide, which we breathe out, and water and light. They create a chemical reaction within themselves called photosynthesis, and they create glucose, which is their fuel, which provides the energy for the plant, and then they also create oxygen, which is what we breathe. So again, these big chemical reactions that look kind of intimidating are actually happening every day in the world around us, and we rely on them to be able to, for our world to be able to function. If we didn't have photosynthesis, none of us could survive because we need the oxygen that plants create. Same thing in our bodies. There are chemical reactions happening second by second, millisecond by millisecond in our bodies that we rely on. So these are really important to give credit to and to understand that God created all of these reactions for a reason. So there is kind of a little graphic on your handout that shows some different types of chemical reactions where chemicals, maybe individual molecules, that shows A plus B individual molecules could end up bonding together in a chemical reaction. It shows some other ones where some molecules are already bonded, they might break those bonds and then form new bonds with different molecules. So especially for older classes, you can kind of talk through what they see in those because we see all of those different types of chemical reactions happening in nature in different ways. And then you can explain that the chemical reaction we are actually going to be working with today is the chemical reaction that happens when we mix vinegar and baking soda. And there's a little image or figure that shows this chemical reaction, shows kind of the shape of those molecules. So vinegar has a chemical in it called acetic acid, and then baking soda has a chemical in it called sodium bicarbonate. And so when those two substances come into contact together, they react to form a new compound called sodium acetate, and then they also form carbon dioxide gas. And we know that gas molecules have a lot of energy. They like to fill the space that they're in, and so we're going to take advantage of that, and we're actually going to be able to see that in our reaction today. So again, you can kind of review that chemical reaction, review what is formed out of that, and then have your class form a hypothesis about what's going to happen when we mix these chemicals. And what we're actually going to do is we're going to mix these chemicals in a bottle, and then we're going to seal the bottle with this modeling clay, and then have a straw poking out the top, and we're going to put some like dish soap over the top. Okay, so we're going to hope that the gas is going to escape, and you can ask them what they think is going to happen with that dish soap. How are we going to see the results of that chemical reaction? Because remember, we're forming a new salt down here, and then we're also forming a gas that is going to want to escape the container and fill the size of the room that it's in. All right, so this is the way it's going to go. For older classes, you can let me know what you would like, but I can send enough bottles for maybe partners to do this experiment together, or for each of your students to do it together. Maybe for middle classes or younger classes, I could send enough for each mom that you have with you to be able to do an individual experiment with a group of kids, so that the kids can be in a little bit smaller groups. You can just let me know what works best for your class, what you think will work. But here's how it's going to go. I've got a little bit of water in this bottle to start with, and then I'm going to add some vinegar. It says a half cup in there. It doesn't need to be exact. Obviously, the more reactants that you add, the longer your reaction is going to go on, but your reaction will go on plenty long. So I'm just going to add a little bit of vinegar, fill it up to about there. Again, you can remind them that vinegar has acetic acid in it, which is what's going to form the reaction. And then the baking soda, you're going to add about a teaspoonful of baking soda. And here's how we're going to do that, is we are going to get a teaspoonful, if I can get it, there's not much left in here. Get a teaspoonful of baking soda, and we're going to put it on a little toilet paper square. And then we're going to kind of fold this up and bring it to a point so it kind of makes a little packet. And that's what we're going to put into the bottle. All right, so what's going to happen is I'm going to put this packet into the bottle, and then right after I do that, the chemical reaction is going to start in the bottle, and I'm going to seal it up. And then while it is sealed up with this straw poking out the top, I'm going to take this solution that I've created that's equal parts water and dish soap. You don't need a ton of it. Make sure you kind of mix it around well with your finger. That's going to help it work a little bit better. Okay, equal parts water and dish soap, just in a little saucer. And as soon as the chemical reaction happens, I'm going to seal this so that the gas needs to escape through the straw, and then I'm going to use my finger to just lightly kind of slide the detergent solution over the straw, and we should see bubbles start to form. Okay, so here we go. We've got vinegar in the bottle, we've got baking soda, again sodium bicarbonate, going in, and you can see the reaction start to happen right away. It'll go on for a while, so it's not like an emergency if you don't get it sealed right away. Okay, so you can see that reaction is happening very nicely. Now I'm going to see if I can get the gas is coming out really fast right now. The bubbles are going too fast for me to even get, there we go. You can see a little bubble form maybe. There we go. So for as long as this reaction goes on, your students can put bubbles onto the straw. Hopefully you can see this in the video. So that gas, again, that carbon dioxide gas that's being formed as a byproduct of this reaction is trying to escape from the bottle, and so we can take advantage of that, and we can actually see that gas escaping as it fills up that soap bubble at the top. And again, we can keep doing that for as long as it's reacting. If some of that sodium bicarbonate gets stuck, you might want to shake it around a little bit to make that reaction keep going. You can have them also observe what's going on in the bottle. This is a reaction that creates a pretty good imagery where we can see the gas bubbles kind of forming and fizzing. All right, so that's our first experiment. And then you can analyze it, ask the class to share what they observed, what their results were. And again, you can remind them of the chemical reaction that was happening and the fact that the reason why we could see those bubbles forming is because we had a carbon dioxide gas that was escaping from the bottle, and we put our detergent on top of there so we could actually watch the gas escaping. So even though we can't see the individual molecules interacting and reacting to form new molecules, we know that it's happening because we can observe the results. So again, God created the world to depend on these reactions, these minute reactions that are happening in our bodies, in nature, in the world around us, everywhere. And we depend on them all throughout our day, every single day. And even though we can't see them, we can observe the results, and we can be thankful that God created those in his wisdom. So the second activity, if you have time for it, is a little bit potentially messier. So make sure that it's just you who's handling this. So this is going to involve iodine and bleach, which are both obviously very messy, but it's kind of a cool allegory that I've used in Sunday school before, and I think it's fun. And it's a chemical reaction, so it fits in well. Okay, so we have 3 cups here, and hopefully you can see though. We have a cup or a glass full of water, and that is just labeled you. So this represents people. We have a glass labeled sin. This has water as well as iodine in it. That's what's giving it the dark color. So this is sin. And then we have a glass labeled Jesus that looks clear. It's got water and some bleach in it. All right, so you can explain that in the beginning of the world, God created people, and he said that everything was good. But then when sin entered the world through Adam and Eve's sin, after that, all people were born with sin. So all people have sin. All right, so we can see you, representing people, now have sin. And there's nothing that people can do to get rid of this sin on their own. But God loves us too much to let us remain in our sin. And so what God did was he sent Jesus. So let's see what happens when we add Jesus. You can see that sin is cleared away. And if you didn't fill up your cup quite so much as I did, you could actually pour more sin, and you could see that even if we keep sinning after we believe in Jesus, because we know we're not going to stop sinning immediately when we believe in Jesus, even if we keep sinning, Jesus' blood covers all those sins as well. And so he washes us clean. So again, this is an example that just conveniently fits in because it happens to be a chemical reaction. But you can help the class appreciate, again, this chemical reaction that God gave us where we can't see the individual molecules reacting, but we know that something's happening because we can actually see the chemical change with the colors changing in our liquid here. And it's just kind of a fun allegory that we can use. This one is kind of messy. And so make sure that I will send along plenty of paper towels and everything, and make sure you're really careful with the iodine and the bleach, obviously. And as long as the bleach is diluted enough, it should be able to go down the drain. Just make sure it's diluted with water so that it's not just pure bleach going down the drain. All right, thank you very much.